This is the few layers to provide the digital identity management. So starting from user authentication, and then once the authentication is in place, we also need to focus on the user data, which must be protected. And then later, once the data protection authentication are in place, then we will look at the user access, for example, SSO for better login experience to different application, microservices, for example, let me go to the next slide. For digital bank, sometimes they have a few services like eKYC, online card PIN reset. So all of these modules can leverage on the same unified platform, which is on the bottom, the universal platform, which our UAS can cater for different authentication needs. This is the basic introduction slide for our access matrix, which covers three main modules. We have the strong authentication, access management, and single sign-on modules, all leveraging on the same unified common platform. And the benefit is, of course, they can share the same, the common admin console, and then leverage on they can use the same set of SDK across these various modules, and we have out-of-the-box support for HSM, and then also we provide backgrade security policies such as dual control, no super admin concept, and then segregation of duty. Okay, so the use cases we cover today will be focusing more on authentication. Over here we can see the multi-factor. Let me on my side. Yeah. So multi-factor authentication on the basic slide introduced last time, we can cater different authentication from different vendors, and then different use cases, login authentication or transaction signing, and then end-to-end encryption. We also have a few modules under this, such as E2EE, ATM, ePIN mailers, and all of our solutions that are compliant to the risk guidelines set by our Malaysian regulatory. Okay. Yeah, so as mentioned, let me start with authentication. So this slide is basically just saying that our on the left-hand side is all the solutions that address the threats over here. So for example, we'll be focusing on the digital signature, the transaction signing, which can help to address the threats for man-in-the-middle attack. Because they are using different channel, for example. And then for end-to-end encryption, it's also very important to encrypt the password or sensitive information on top of SSL to prevent network sniffing as well as back server infiltration. So our server can support different authentication methods for strong 2FA implementation. This is under the aggregated controls. So this is just a mapping. And then, as mentioned, for digital trends right now, transaction signing is quite popular for the digital banking. And then most of the projects will be proposing mobile tokens because it's for the user experience as well as the security. And then if they have the mobile application, normally we will suggest to have an embedded mobile token into the mobile application itself, so that user does not need to have two applications. Instead of two, then they only have one application. Okay, and then on top of that, once the mobile token is embedded into the application, then we also can include the RSP to protect the mobile application from different threats during runtime and also at rest. Okay, so just now as mentioned, we can have two modes, standalone and embedded. Offline mode is the OTP login, which I'll show the use case later. And then online mode, we have push and login, or we call it as zero login or passwordless sorry, that one is scan and login. And then the embedded, yeah. Okay, this is just more detail for just now what I mentioned. For offline mode OTP, you don't need to have internet connection, so similar to hardware token. And then for online mode, for push and login and scan and login use cases, I'll be showing in in another slide later in more details. Okay. So I'll be showing the demo to activate the token using YesSafe. Let me Okay. So over on the right hand side is we will be downloading the YesSafe token mobile authenticator from the Google Play Store or App Store. Okay. The user guide normally will state which version you'll be downloading. So for example, if for the latest AM access metrics, then you need to download the YesSafe token 4.0. So once you downloaded, then it's set up gesture or the pin. Okay, and also can leverage on the device biometrics for login too. And then once this is done, then you can log into the token activation portal. Okay, there will be a QR code for you to scan. Okay. So over here we have our QR code. So using the mobile authenticator, just scan the QR code, then enter the code display into the mobile token authenticator. Okay, after that, there will be another activation code. Once this is done, then the mobile token is activated. Okay, so basically this is the token activation process. Okay. Right now, this demo is for 2FA login as well as transaction signing. Okay. Okay, so this is a normal simple password, ID and password login. Okay. This is just an example of a banking application. And then the next one is OTP login. So later we'll be using the mobile token authenticator on a mobile device to generate the OTP. Okay. So we'll be showing different login methods, use cases. And then the third one, we'll be using scan and login. So using the mobile token authenticator, you can switch on the camera and then scan the QR code display on your browser to log in. Okay, so scan to login and push and login is they are more seamless for the user experience. And then because this one considered advanced mode because you need to cater for the mobile token for both push and scan login. Okay, so this one is upon login, user will be receiving a push notification login request. Okay. And then for easy login, it's very similar to scan to login, but you don't need to enter the ID and password. Just simply scan the QR code, and then user is authenticated to log in. Okay, the next bit is about transaction signing. So on the banking application, fill in the normal details for transaction. Okay, this one is using a scan and sign. So the OTP will be generated after you scan the QR code. and then you'll be seeing that the status is successful. Yeah, over here. So the next one, okay, let me skip a bit. Yeah, is a QR code. So different, we can support different use cases for transaction signing as well. So this one is just simply scan the QR code. And then authorize on the phone. Okay, so same thing, the status should be successful. Okay, let me skip a bit for the next use case. So the next use case is push authorization, push and sign. So upon confirming the transaction on the mobile phone itself, receive the push request. And then same thing, successful. So the last use case will be showing a negative test case where if user click cancel instead of authorize the transaction, by right, the transaction status should be canceled. Yeah, as shown over here. Okay, so this is the demo. So next we'll be showing the UAS basic information. So that our UAS, as mentioned before, is the vendor agnostic server, so that the customer does not need to be tied to a single vendor. And then we also support different OTP tokens such as hardware token, mobile token, SMS OTP, and we can also integrate with external data store like Windows AD or LDAP for the 1FA. And then we can also have authenticate to social network account like Facebook or WeChat. And then just now, as shown just now, we support different authentication use cases for authentication and also transaction signing. And we also provide a comprehensive token lifecycle management to manage the mobile token. And we provide out of the box for support for HSM for the encryption keys or protect the password in storage. This one is about the token to configure or manage the token, for example, different token status or different token function like a token assignment, which one user can have many tokens for different application purpose, or many users can be sharing the same token. So this can be configured. And then token activation, just now we have gone through the demo. And then yeah, so starting from token issuance, token activation, all this we can cater for. And then this one is more to employee. So we can also have a E2FA. And then same can apply SMS OTP, mobile token or hardware token. So, but right, I understand that we will be focusing more on external facing. So this one is just for your knowledge. We also support for E2FA. Okay, so for external facing, these are the target applications for digital, for example, for digital banking, FSI, and then different modules over here, as we can see, end-to-end encryption of the 1FA password and mobile token with various use cases, transaction signing. So these are all the keywords that you should look out for. And characteristic user base normally is a big user base. Otherwise, because for if E2FA is a different case, and then if whether the customer need to integrate with HSM or not, and our iSpring solution has also has a lot of experience in implementing the B2C or B2B authentication. So this one we will move on to the end-to-end encryption. Okay, so for E2EE authentication is to protect the password, and then for higher security, we can also do the password verification inside HSM. So typically used in internet or mobile banking, and then our E2E is compliant to the risk regulation also, and it's very important to protect against insider attacks or man-in-the-middle attacks. Oops, sorry. So as mentioned, is to mitigate the threats of cyber criminals stealing the password and performing brute force attacks. Hence, E2EE is very important, highly recommended on top of SSL protection of the password. Okay, so the concept is because normally the organization will only relies on SSL to protect the 1FA or the sensitive information. But because the web server is in the DMZ, so if the SSL is turned off, then the password will be exposed in clear text. So the same thing will happen at the backend server as well. If the SSL is terminated, and then the password will be exposed to. Okay. So these are the vulnerabilities, the attacks like a Heartbleed bug, and then the TRS 1.0 is quite is very vulnerable also. Yeah, but what I'm trying to say is SSL is still is not that secure because it's vulnerable to the attacks that I mentioned just now. That's why E2E is very important on top of SSL. Because once we reach the web server, if the SSL is turned off or there could be other breaches, then the password will still remain encrypted, and then it will only be decrypted at the backend server, or if a HSM is included, then the point of decryption is inside the HSM. Okay. So let me show the demo for the authentication. So this one, let me pause. This one is calling the pre-authentication for the E2E libraries to, once you access the browser, this one is, actually it will not show, but for this demo purpose, it just show you how it works. So normally user will key in the ID and password, and then once the user click on login, then the password will be encrypted. Over here, you can see the R pin is the encrypted password. So the password has been encrypted. Yeah, so it's actually quite, it's actually quite straightforward, but at the backend side is calling the E2EE library. For the user experience is transparent to user. Okay, so it applies the same for the reset password as well. Okay. So when you reset password, both the old password and the new password will be encrypted. You call the E2EE libraries. Okay, so same thing, once user click change password, we have our encrypted password. Okay, so the last part is just showing that the password that the new password, we are able to use the new password to log in. So every time you access the browser, the pre-authentication session will be launched at the back end, of course, not this one is just for demo purpose. So this is the new password. So same thing will be encrypted. Okay. Okay. So for the components, backend components part, just now the demo is on the browser itself, which the same can be applied on the mobile. Okay, and then this is the web server. The app server will have will call the E2E API to the UAS server. And then if HSM is included for the password verification, then the password will be end-to-end encrypted from the point of data entry to the point of decryption, so that no one can access the password in clear text. We have a few modules under E2EA. We have E2E of data protection in transit, EP mailers, as shown over here. And then to replace the 1FA, we can also leverage on the phone-based biometrics for passwordless login. Okay, so for the device-based passwordless authentication, is just basically replacing the 1FA. So first, user will log in using the biometrics like Touch ID or Face ID, and then the password is derived from the device storage and is encrypted with the E2E libraries, and then is verified against the authenticate to the UAS server. Okay, so this is for user is quite seamless and also at the same time provide a better security as the password is unknown outside of the device. And then the next module we have is the ATM PIN translation or protection. So the E2E is to protect the credit card information, for example, the credit card number or the CVV. So this can be applied when a user want to use the credit card information to apply for internet banking, normally for digital banking. And then also if another use case is if the user wants to reset the PIN over the internet so that the user does not need to visit the physical branch. Okay. So this is the overview of the solutions that we offer. So we have gone through the mobile token authenticator for different authentication mechanisms. SSO will not be focusing, but this one is after authentication is in place. Then if the user has a different application, maybe more than 3 applications, then SSO can be applied. And then for the password protection, we offer E2EE, and then the data protection is another module, and we have out-of-the-box support for HSM. And as mentioned just now, after mobile token authentication, we can also protect the mobile token application, which we offer RSP. And the onboarding process, we work with our third-party partners for the eKYC solution, which we will not cover today. And the benefit is all these different modules for authentication, SSO, they are built on the same common platform. So one server. Okay. And then these are the components. So basically we have already sort of gone through, it's the same components, web server, our UAS server for the E2EE. And then for the user MFA, they are using leveraging the same pointing to the same UAS server. And then we can point to internal or external user data store. Okay. Yeah. So over here, the mobile token is embedded into the mobile application. Then we have mobile token SDK. Then we can also have a E2EA SDK for the data protection. And for the mobile application protection, we will have the RSP solution. Okay, so what are the questions that normally you will need to ask the customer? These are the list of questions that you need to consider. How many servers included, for example, UAT, SIT, production. Production normally will have 2 servers for HA purpose. Number of users, so that we can know the peak logins per second also. Number of logins per day, whether HSM is required and what type of applications need to be integrated, web or mobile, whether the integration is via REST API or Radius. And then the authentication mechanisms, of course, whether end-to-end encryption of password, which module. So these are those other modules for E2EE. Okay, so just to show a case study in one of our major customer in Malaysia, all these solutions have been successfully implemented. So we have our UAS server implemented in the bank, and then using a mobile token from YesSafe embedded into the mobile application, and then also have a hard token from OneSpan. So we are vendor agnostic. And then also we have implemented the App Protect Plus for the RSP solution for the mobile app shielding for their retail banking. So over here, M Online, M Access Biz, so you will know what bank is this already. Okay, so this is the customer profile. So it's one of the largest tier 1 bank. Okay. And as mentioned, very important, all our solutions can comply to the RMIT guidelines for end-to-end encryption, MFA, and also RSP also. Okay, later I think we have a slide on the RMIT. Okay, so these are the benefits, our strength. And then this one is for internal, if E2FA, and external facing, so have two parts. This is another second case study, which is a bank in Thailand. So almost the same, but they are using a hardware token OTP, and they also have a page HSM for the ATM pin translation. Okay. So this is the customer profile. It's one of the leading banks in Thailand, and then point to the LDAP, port 2 modes, cloud and on-prem. And for the database server, we can also integrate with three major database like MySQL, MS SQL, Oracle. Our application server default one is Tomcat server, but we can also support a JBoss web server. And then for the user data store, as mentioned, we can integrate with external user data store as stated over here. Okay. Okay. So this is just a recap of what we've gone through. Okay, so the major features I've covered also. Okay, let me go to the, okay. So the token policy for the, this one is the management. We can have configure the OTP length, the OTP validity time, the different encryption algorithm to be used. Okay, so we have our in-house YesSafe token plus, and it's a time-based OTP, and also can leverage on a mobile biometrics for seamless login. And then we also provide a token activation portal to activate the mobile token. And then for mobile application, we also provide the SDK to be embedded into the application. Okay, so this one is the basic authentication. This one, just now we have gone through the demo. So mobile token use cases, we have activation, offline verification, and online verification. I'll go through it one by one. This one is the metrics. So this one is quite useful. Let me on my pointer again. Okay, so for offline OTP, basically it is already used out of the box, or white label and SDK. White label is you just use the standalone mobile token, and SDK means you embed it into the mobile application. And then for advanced mode like push and scan, need to customize on the mobile token application. And then we support different vendors. YesSafe so far, OneSpan, Google Authenticator, Microsoft Authenticator. And then for the SDK, we can integrate these three vendors. And for project-wise, this one, normally if you have a SDK, you have a mobile application. Okay. So these are the consideration, online or offline, whether the token activation portal is needed, because sometimes for the online activation, token activation portal is not required as it's embedded inside the mobile application. So later I'll show the use cases for a better idea. Okay, so just as mentioned, with or without an activation portal. For offline, actually, the token activation portal is also not necessary because the activation code can also be delivered by email. But normally, this approach is more suitable for E2FA. Okay, and then for online use cases, if with portal is like the demo that we have gone through. Without portal, then it's handled inside the mobile application, which only valid for the embedded, the SDK one, not the standalone. Okay, so this one is the use case for token activation. So just now in the demo itself, the QR code will be displayed for user to scan using the mobile token application. And then we'll prompt for user to key in the token pin, and then token activation is successful. So this one is by scanning a QR code for token activation. And then the next one is within the mobile application. So this one is more seamless as the user just access the normally the banking application, and then there's under the menu, just click on activate token, and it will receive a SMS for the activation password. And then just enter the password. Same thing, sometimes based on the configuration, it will prompt for user to enter the token PIN, and then the token activation is successful. So there are two ways. And for login, we have push to login use case as shown here. First, the user will log in into the login page. And then once upon login, user will receive a push notification login request, and based on the configuration, user can enter the PIN or leverage on the device biometrics to log in. So once login successful, then the user will be able to log into the browser. Okay. So another use case is push to sign. This one is for the transaction signing. So first, user will create a transaction on the transaction page, and then once submit, user will be receiving a push notification for the transaction itself. So same thing, user will log in using either PIN or Touch ID or Face ID. And then once login verification success, then user will be receiving the transaction, specific transaction. So user can either approve or reject the transaction. Once approved the transaction, then it's successful. The transaction is successful. Okay. So another use case other than push, we have scan. So scan, just now in the demo, is display a QR code for user to scan. And then this 3A and 3B is based on the configuration. And then once scan successful, then the login, user will be able to log in. So it's pretty straightforward. And then for transaction signing, we also support scan to sign. So same thing, user access the transaction page and then create a transaction. Once submitted, then the QR code will be displayed for user to scan using the mobile phone. And then user will be prompted to enter PIN or the device biometrics. And then it will display the transaction specific to the what user has, especially the previous transaction, this transaction over here. So the details are the same. So user once approved, then the transaction is successful. So over here, let me get my pointer. So over here, as mentioned, if the mobile token is embedded into the mobile application, then we have the SDK, and then the provisioning web service is for the token activation, and the notification web service is for push use cases. So is to push the messages via Google Cloud Messenger or the Apple push notification service to the user's mobile device. And then we also can support SMS OTP via this SMS gateway to the user's device too. And our UAS server over here, we can integrate with external data, user data store. And we have also HSM is optional. This one is to verify the password or OTP, and as well as protecting the token seal of encryption keys. So this is the overall architecture diagram. Okay. So for the question, similarly, normally the basic one, we will ask the number of environments, number of users, and type of application. Whether only web, internet banking, or mobile banking is included as well. For the hardware part, the questions that we will need to ask is what are the number of logins per day, the peak hours of number of logins, and how long do they want to keep the audit. So it will affect the hardware, the database sizing. Okay, and then the next question is whether is it for internal or external facing, and then whether it's a standalone or SDK mobile token. And then normally online mode is preferred, but we also have option for offline mode if the customer do not have offline internet connection. And then the activation, is it with a token activation portal or is it seamless? We have two approaches as shown just now in the mobile token use cases, but mostly the digital bank, they will have a mobile application, so they'll go without a portal. Okay. Yeah, that's conclude my presentation today.